Hello everyone, this is Banu Sheikh. This presentation is about simulated annealing search. Simulated annealing search. In this presentation, we are going to discussing about physical annealing, simulated annealing, state space diagram with its example. First, we are going to discussing about what is physical annealing. This simulated annealing algorithm is based upon physical annealing in real life. So simulated annealing it is based on real life example. Okay, physical annealing is the process of heating up a material until it reaches an annealing temperature, and then suppose when we heat up a material, after some time it will cool down. It will be cool down when its temperature goally to change its state to a desired structure. When a material is hot, the molecular structure is very weak, so it is more susceptible to change. When material is slowly cooled down, the material is structure is very hot and less susceptible to change. Any material like glass, when it cool down, after when it is more heat and it more having this more temperature, so it will change to its desirable state. This is the diagram of the physical annealing. So it is a real life example when the temperature is heats, then it changes to its desirable state, whatever which type of material you want. So the thermodynamically equation of the physical annealing. This is the thermodynamic equation. P of delta E is equals to E power delta E by K into T. Here P is the probability function. P of del E is the probability function. Del E is the energy magnitude. When the material it helps, its energy is more. T is the temperature. So here temperature is the variable parameter. When the temperature rises, if the probability of the function is more. When temperature is slowly cool down, its probability function is less. Here K is the Boltzmann's constant. Here Boltzmann constant is the constant value, which value is equal to 1.83 into 10 power minus 23 joule per Kelvin. Joule per Kelvin is the unit for heat. Simulated annealing. Here, simulated annealing is the sophisticated global search optimization algorithm, and it is a modified version of the hill climbing. So it is a modified version of hill climbing. This is appropriate for non-linear objective functions where local search algorithms do not operate well. This searching algorithm is more optimized and better searching technique where other algorithms do not. Those algorithms are good, but simulated learning is more optimized searching algorithm. So simulated annealing solution is start by shaking hand. So when we are giving a handshake to anyone, your temperature is more when the temperature rises to more and then gradually reduces its intensity. Simulated annealing is very useful for complex situations for a lot of local minima. This is the graph for finding local minima. Here, this is the least value or absolute value at certain interval. Nothing but here t is the variable parameter. This is the local minima. So this is the least value. This is the local maxima. Its function is y minus f of x. This is local minima. Here global minimum is here. This is the global minimum. Finally, the greatest value or maximum in a certain interval. So, example for simulated annealing. Example or ping pong ball. Suppose when we throw a ball to a hard surface, let us imagine the task of getting a ping pong ball into the deepest crevice in a very bumpy surface. If we just let the ball roll, it will just reach the local minima. If having any other local minima, if we just shaking this ball, so then after certain time, it reaches to the local minimum, and then the ball reaches to finally global minimum. So when we shaking the ball, it's very sometimes it will take more time. Then finally it reaches to its minimum, global minimum. So this is the graph. Suppose if we throw the ping pong ball into the local minima, so here when the ball is shakes, then finally it reaches to up to certain time, it reaches to its global minimum. Simulated annealing techniques. How? Simulated annealing improves the strategy through introduction of two tricks. So simulated annealing improves the statistics by using of two tricks. These algorithms chooses very random trick instead of picking best one. After certain time it get improves, then finally reaches its destination. Then finally global minimum will reach. Otherwise, it moves some probability function between 0 and 1. Here, ping pong ball throw into some deepest curve. It is not the global minimum. So, we will reach the global minimum by through shaking the ball or maybe other tricks. So, finally, it reaches to its global minimum. Here, based on this algorithm, the algorithm uses the simulated annealing algorithm uses e power minus del d by t. So the probability function is in between. Always the probability is in between. Every probability for each function, the probability lies in between 0 and 1. Here, where d is the change of distance. Suppose when we throw the ball, it reaches to some distance first, nothing but local minimum. After certain time, it takes after some time when it reaches to its global minimum. In that time, it varies its distance. Here T is the temperature. R is nothing but the probability function between the probability always lies between zeros and ones. So it always between 0 and 1, a random number in the number. So its probability may be 0, 0.1, zero point 0.1, 0.2, 0.3 and so on until it reaches to 1. The always probability lies in between 0 and 1. This is the algorithm for simulated annealing. Simulated annealing problem schedule. So then returns to its solution state. Suppose when we throw the ball, it reaches to its final deepest curve. This is the local minimum. So this is the final answer. Then returns from this answer. Here current. Suppose it is not the global minimum. So what we do? We will do to perform more and more better in a optimized way. So finally it reaches its destination, then return to its global minimum. Here del is the change of nothing but here energy variable. Energy nothing but the time taken to perform it takes more time. If del is greater than 0, then current move to next. Suppose this is the local current is the local minima. Then after some time it reaches to its maximum. So it becomes next. Then finally returns probability del E by T. Finally end. This is the algorithm for simulated annealing search. Simulated annealing uses where it uses simulated annealing used to solve VLSI layout problems. VLSI means very large scale integrated chips. Where simulated annealing is used in that chips. It had been applied widely to factory scheduling. It also applied to various factory scheduling and other large optimization tasks. Simulated annealing searching algorithm is more effective than other searching algorithms. Okay. Finally, this is all about simulated annealing search. So always the probability function lies in between 0 and 1. This is all about simulated annealing. Thank you.